Inequalities and set notations, pre-calculus. First of all, what is set notation? Set notation is another way of expressing an inequality. So where we used to have like a number between less than signs, it would be, that would be parentheses, but less than or equal to signs, we use brackets. For example, if we had a solution set that was like -5 is less than or equal to x is less than 8, that would be a bracket -5, and it's a bracket because it's less than or equal to for the -5, comma 8. You don't write the x at all, just the numbers. And but because this one's not less than or equal to, it's just less than, it would be a parenthesis. So this is the set notation of that. Basically, the equal to bars means bracket, not equal to means parenthesis. And what this is, it's just listing all the numbers. So if you have a parentheses, say 2 to 5 parentheses, this means that there's no equal to bars. Let me write that 5 a little bit better. 2 to 5, and so since there's no brackets, there's no equal to bars. So this list of numbers would be 3 and 4. That's it. 2 and 5 would not be included, but if you had bracket 2 comma 5, this would be the, sorry, bracket there. This would be the numbers 2, 3, 4, and 5. So a bracket is like the equal to bars, less than or equal to, meaning the boundary numbers are included in the set there. So we'll come across this a little bit. Basically, we're going to work with set notation instead of inequality notation for these answers. So first, just a little practice. 2 is less than x less than 5 would be the same as the 2 comma 5 in parentheses. If they were less than or equal to, then we'd be looking at the bracket answer. All right. And x is greater than or equal to -4. Okay, now greater than or equal to -4 means -4 to what? That's where infinity comes in. So if we were to like look at this on a number line, for instance, here would be -4. X is greater than or equal to -4, we know is a closed circle and pointing this way towards infinity. So what we're really saying is -4 to infinity by saying greater than or equal to -4. So -4 is the least of this set because it's greater than -4. So that means that it's going from -4, and because it's greater than or equal to, we'll have a bracket for -4. And then it's going to infinity. Now, even though we have an equal to bar here, you have to be careful that whenever you're dealing with infinity, it's always going to be a parenthesis. Or negative infinity, which we will see in some of these problems also. So if this was, say, like less than, it would be infinity to 4. But infinity and negative infinity always get a parenthesis because you can never actually equal infinity. Because infinity is, well, it's kind of a strange concept. Don't want to get into a philosophical discussion here. But basically, when you see infinity there, make sure you always have a parenthesis there. The equal to bar is really more for the numbers. So that's the case there. But again, go back on this concept of negative infinity. If we had something that would say x is less than or equal to -4, then that would be pointing the other way. So that would be going from negative infinity to 4 to -4. And again, -4 would still get a bracket because it has a less than or equal to, but negative infinity would get a parenthesis there. I mean, hopefully your infinity signs are a little bit better than mine are. It's basically a sideways 8. I know some students actually will turn their piece of paper horizontally, draw the number 8, and then spin it back. So if you ever really struggle with that, you could try that. All right, let's try a couple of actual problems where you solve the inequalities. So basically what we're doing is we're going to solve the inequalities and then write our answers in the proper interval notation. All right, this is one where it's kind of, x is kind of between things already. And so what you do when you have this situation is you need to work your way out, and you need to do it on both sides. So first thing, I'm trying to get just x alone in the middle here. So I need to first minus 8 away, and I do that on both ends. It's almost like if you had like 5 equals 2x equals 8, it's almost like solving two equations at once where you can divide 2 to both of them kind of thing. That's kind of what we're doing here. So minus 8 everywhere, that'll get us -2. These are greater than or equal to signs. -2x greater than or equal to +4. Then this is, of course, negative 2 times, and so we're going to divide by negative 2. And then what's going to happen here is the golden rule of inequalities, that you've done a little bit of inequalities every year for probably 2 or 3 years, and that one special rule always comes up, that you must flip the inequality sign if you divide by a negative. So there's a B there. So see how we're dividing by negative 2? That means I need to flip these inequality signs from greater than signs to less than signs. If this was, say, a positive 2, and we divided positive 2 everywhere, then you do not flip the signs. It's only when you divide by a negative that you flip those signs. And so I still will do my division here. So let me continue the problem over here where there's some space. Negative 2 divided by negative 2 is 1. My inequality sign of greater than or equal to switches to less than or equal to. The equal to bar stays. Negative 2 divided by negative 2, of course, is just x. And then, again, my inequality sign will flip to less than. And 4 divided by negative 2 is negative 2. Oh, wait, hold on. I messed up here, didn't I? This is negative 10, not 4. Hold on. Let me check my math here. 6 minus 8 is definitely negative 2. But negative 2 minus 8 is negative 10, not 4. Let me go back and fix that. Sorry about that. Get that blue back up. So negative 10 divided by negative 2 is positive 5. And I see that so I'm going from 1 to 5. So I know it's going to be 1 comma 5. The question is parentheses, brackets, a little bit of both, and the greater than or equal to bar, less than or equal to bars, but the equal to bar tells me it's going to be brackets. So that's why my answer is choice C here. Let's do one more. Number 5. All right, just a bunch of algebra to do around the problem. You know, always watch out for the if I divide by negative, flip the sign kind of thing. But let's just see what happens here. I could distribute this out. Negative 10x plus 5 minus 3 greater than or equal to negative 4x minus 4. All right, I distributed it on that one too. So it's negative 10x plus 5. Still have a minus 3. Stayed. Negative 4x minus 4. Okay, I can certainly clean that up a little bit. So negative 10x plus 2, right? The 5 minus 3. Then greater than or equal to negative 4x minus 4. Let's see, I could add 10x to both sides, and that would make it 2 is greater than or equal to 6x minus 4, and add 4 to both sides would be 6 is greater than or equal to 6x. And lastly, divide positive 6 on both sides as 1 is greater than or equal to x. Now, a couple of things. This problem could have gone a couple of different ways at this step. Notice that I decided to move the x over here. I didn't have to do that. I chose to do that because I think that's what a lot of you guys would do. But if I had added 4x to this side, that would have been fine. I just would have had negative 6x here, but then I'd have to divide by negative 6, which would cause me to flip the sign. But you know what? It's going to end up being the same thing, because when you get down to this point, notice that my variable here is on the right. We always want the variable either in the middle between two less than signs or on the left if it's with a single number. So what I'm going to do is I'm going to rewrite this so that x is on the left, but because I'm switching the order, I have to flip this sign from greater than to less than or equal to 1. And if you think about it, this really is the same thing, because notice that the arrow is pointing to x. The arrow is still pointing to x. Instead of saying 1 is greater than x, well, that's implying that x is less than 1. Like if we were to pick a number here, like 0, like 1 is greater than 0, well, it's the same thing as 0 is less than 1, right? But it's just a little bit easier, I think, when the variable's on the left side. So x is less than or equal to 1. Less than or equal to 1, since x is not between two numbers here, that's where infinity or negative infinity is going to be involved. And because it's less than, negative infinity is going to be involved. So we're dealing with negative infinity to 1, because the numbers less than 1 go down to the left side. And negative infinity will always get a parentheses, but our 1 will get a bracket because it has an equal to bar attached to it. and that's why our answer is going to be choice B. All right, so it's a lot of just inequalities and solving basic equations and that kind of stuff. Sometimes you have to work two sides simultaneously. Um, don't forget if you divide by a negative to flip the inequality sign. And then it's just working with the set notation stuff, which is not too bad. Basically, if there's an equal to bar, it gets a bracket. If not, a parenthesis. And infinity always gets a parenthesis. Okay, so we'll practice this tomorrow.